Factoring, I think, is the single most important thing which you should know perfectly for getting into calculus, right? So here I've taken two examples. They are actually simple examples. And uh, this is only a reminder for you that you should brush up your knowledge about factoring before getting into calculus, right? So question number 8 is factor the following. And I've just given you two examples here. Is x cubed minus x squared minus 16x plus 16. Well, here we have a very simple case, 4 factors, and we will do factoring by grouping. As you can see, if you see the first two terms, x squared is common. So let's take x squared common from first two terms, and we are left with x minus 1. And in the next set, we have 16 common. So 16, and we get x minus 1. Now, if you see these two terms, then x minus 1 is common, right? So we can write this as x minus 1, and we get x squared minus 1. Correct? Now, don't stop here. Some students stop here. You have to factor completely. X squared minus 1 can be written as x plus 1 times x minus 1. Right? So let me write it here after that. So it is x minus 1 times x squared can be written as x plus 1 times x minus 1. Correct? So it is difference of squares. X squared minus 1 square, right? Now you can combine these two, and you can write x minus 1 whole square times x plus 1. Now that is how you completely factor the given expression, right? So that is how you do these. But at times, you can't group it. Let us say we have something else, not 16 here. In that case, you have to find the possible factors. So all the factors of this constant could be the possible factors, and then use remainder theorem. Plug it in that value. Whichever gives you 0 could be a part of factor, correct? So you can brush up your knowledge about factoring polynomials and then start with calculus. Now this one is actually difficult for some students. Now here we have rational exponents. Now in calculus we are going to use rational exponents in a huge way. So you should get to understand them better. And that's the reason why I have taken this example here. Now, whenever you factorize, for example here, the highest power which was common was x squared. So you factored that out, right? X squared was the power which could be common, right? In this case, since this is the lowest power, only that could be common. So it's a good idea to factor this out, right? Now in numbers 1, 2 and 8, we cannot factor any number out. So all the coefficients, they don't have a common factor. But what we can do is, we can factor x to the power of minus half. So that is to be factored out. Now, if you factor here x squared, for example, then what do you get here? 3 minus 2, which is the power is 1, right? And 2 minus 2 gives you 0, and so x to the power of 0 is 1. That is what you do. So here also you will do the same thing. So I'll write here x to the power of 3 over 2 minus of this. Do you see? Minus of this get added. Do you see? This get added. So you get x to the power of 3 over 2 plus half. And here you'll get 2 times x to the power of half minus of minus 2, minus half, which will be plus half, right? And minus 8. Since minus half plus half will be 0, so x to the power of 0 will be 1. We have already factored this term out. So this is what we get, right? So given expression or trinomial in our case, I should not call it trinomial. This is not a monomial, right? Since the power is negative half, right? And all these powers are not natural numbers. So they don't belong to the set of monomial, binomial, or polynomials, correct? So we are not talking about polynomials here. So this expression gives us x to the power of minus half, which I can write as 1 over square root x. Let me write this because just to show you, it could be written like this, right? And this is what? 3 plus 1 is 4, 4 divided by 2 is 2. So we get x square here, plus 2 times x, right? Minus 8. So we have factored this, right? And now we do get a polynomial here, right? We have a quadratic equation. Now, here we can apply product and sum and factor it. So we are looking for now two numbers whose product should be minus 8. So two numbers whose product should be equals to minus 8. And when you add them, you should get plus 2. I mean, p plus q equals to 2. So what could be those two numbers? This is what you're looking for. So those could be numbers are 4 times 2, right? So 4 times 2, and since you need plus, so 4 is positive and 2 is negative. So the numbers are plus 4 minus 2. When you multiply plus 4 minus 2, you get minus 8, right? So I can factor this and write this as 1 over square root x times x plus 4 times x minus 2, correct? So that is how we are going to factor the given expression, right? So this is what we get. So that is a reminder of you of factoring techniques. So we use product and sum, and we did group factoring. So we did variety of things here, and also difference of squares, correct? So remember all these things and brush up your knowledge of factoring before getting into calculus. Thanks and all the best.